Now let's see case 3, the full depth asphalt pavement. There are thick asphalt layers directly above the subgrade. Again, step 1 is to try pavement composition. We have size 14 asphalt and size 20 asphalt and subgrade with CBR of 5%. And it is semi-infinite. Step 2 is for elastic property of subgrade. As we have done this a few times, I won't go into more details here. There are no granular and cemented materials, so we could omit step 3 to step 5. Step 6 is the same as that in case 2. We have the E and mu for both size 14 mm and 20 mm asphalt. Step 7 is to adopt the subgrade strength criterion. Step 8 is not relevant as it is for cemented material. Step 9 is to determine fatigue criteria for asphalt using this formula. Where the RF is taken as 0.67 from table 6.15 for 97.5% project reliability. And again, the effective volume of bitumen, the VB, is taken as 11%. Step 10 is to determine the design number of standard actual repetitions, SAR, for each relevant distress mode. From the given condition of NDT SAR5 over ESA, SAR7 over ESA, and ESA over HVAG, we could work out DSA, DSAR5, and DSAR7. In previous case, we convert the unit to ESA because we need to plug in all values in total allowable loading formulas. But for this case, we don't need to calculate post-cracking as there's no cemented material. So we use damage units of SAR5 and SAR7 for comparison. Step 11 is to assume approximate standard actual view loading. Step 12 is to determine 2 critical locations, the top of subgrade and bottom of asphalt, to calculate strength from software circling, both for directly beneath one of the loaded views and midway between the loaded views. From circular software, we are able to obtain the maximum strength for asphalt and subgrade in step 13, and the results are shown in the below table. For the asphalt, the maximum strength occurred between 2 views, and for the subgrade, the maximum strength occurred beneath the views. Step 14 is to calculate allowable traffic loading, both for asphalt fatigue and subgrade permanent deformation. Next step is to compare the allowable traffic loading to the design traffic loading in terms of SAR5 and SAR7. Step 16 is the conclusion. We concluded that since the allowable loading for each distress mode is greater than the design traffic, this trial pavement composition is acceptable. I hope through these 3 cases, you are able to master the design procedure of flexible pavement. For the circular software, it uses the cumulative damage factor, the CDF, which is the ratio of design traffic and allowable traffic loading. They have to maintain the same units to work out CDF. If the CDF is less than 1, then the road is safe with excess capacity and the CDF represents the ratio of lifespan. If the CDF equals to 1, it means the road has just reached its life. Otherwise, if the CDF is greater than 1, then the road has exceeded its life and been damaged. Obviously, additional loading will cause further damage to the flexible pavement. Now it is the summary of this lecture. We have learned the method to calculate the design traffic NDT in terms of HVAGs using equation 14. Then the mechanistic procedure to estimate the average number of axles per vehicle group and HVAG from WIM, weight in motion data, based on the sum of the proportion of steer axles, SASD and TASD. Next are the concepts of different units of traffic loadings, HVAG, ESA, SAR5, SAR7, SAR12, based on damage or distress models. We also learned the mechanistic procedure to estimate damage indices, for example, ESA over HVAG, SAR over HVAG, SAR over ESA. Finally, we go through 3 typical flexible pavement design cases. The mechanistic and empirical procedures to design a flexible pavement with thin bituminous surfacing, normally less than 40 millimeter, and mechanistic procedures to design asphalt pavement containing cemented layer. In this case, we have calculated the total allowable loading from both pre- and post-cracking traffic loadings. Finally, the mechanistic procedures to design the full depth asphalt pavement. Okay, well, that's the end of our lecture today. Thanks for listening and have a wonderful day.